Okay, so our objectives for today are just to define ratio. This is something you should have done in 6th grade, maybe even 5th grade ratios. So we'll review what one is. We will write some ratios. We're going to write and identify equivalent ratios and compare ratios. All of this really should be a review lesson. So hopefully it is for you. But we need to review this, have a good foundation to lay for what we're going to be doing next. Okay, so first the definition. A ratio is a comparison of two quantities by division. So when we write ratios, the most common way that we are going to use ratios is as a fraction. So we're comparing two numbers to each other by division or by writing it as a fraction. So you could actually put in parentheses here, fraction, because fractions mean division. That's how we find out what the decimal equivalent of a fraction is by dividing. Okay, this leads us right into objective 2, which is writing ratios. There are 3 ways that we can write ratios, so we're going to look at all 3 of them, even though there's only one we'll be primarily using. So we have a little cutout of a piano keyboard, and we have a red box around just part of it. Piano keyboards repeat in patterns of 2 and 3 black keys, which keep repeating over and over again. So if any of you have played the piano, you know that's how you find what the white keys are, is by the configuration of black keys. So if we were to write a ratio to express the ratio of black keys to white keys in this section, I have 1, 2, 3, 4, 5 black keys to every 1, 2, 3, 4, 5, 6, 7 white keys. So there's a ratio of 5 to 7. And that's how I'd write it, just using words. Does anyone know another way I could write? I'm trying to fix that. It's not coming out. I think my thing's stuck. Okay. Ugh. Just lost it. Hang on, let me reconnect. Yeah, it's still recording, so it can still hear us, but it's probably showing all this on the screen. So people watching the video get to see us connecting too. Okay, while we're waiting, what's another way I can write a ratio? Does anyone know? Hillary? Yeah, I can write it as 5 over 7. That means 5 to 7 also. Ben?
5-7?
Not a dash.
Oh, that's what I thought.
Spencer? The 2 dots, the colon. So you could write 5 to 7. Those are the 3 ways. The way that we are most commonly going to use is 5 to 7. Okay. Now, on this side, Austin, question? Is it an emergency? Yeah. Okay. Yeah, I'll write down for both of you for these an emergency. All right, ratio of black keys to all keys. This is a little different. Can anyone tell me what that ratio would be? Sammy?
Say all the black keys and wait, just apply black keys.
It's the ratio of black keys to all keys. So all the keys in our little square.
75.
No, not quite. You're doing white keys to black keys would be 7 to 5. Caleb? 5 twelfths or 5 to 12. There are 5 black keys to every 12 keys total. So if there's 5 black and 7 white, that's 12 keys altogether, right? So 5 to 12. We can also write that with the word 2, 5 to 12, or we can write it as the fraction 5 twelfths, 5 to 12. Okay, any questions about this? Okay. On to objective 3, write and identify equivalent ratios. It asks us to write a ratio equivalent to 4 to 5. Equivalent means what? Equals. Equals or same as. Equivalent ratios are just like equivalent fractions. So if we are writing a ratio equivalent to 4 to 5, we can think of that as the fraction 4/5. Any fraction that is equivalent to 4/5 is also an equivalent ratio. How do we find equivalent fractions? What could we do? It's kind of like the reverse of, you know how when you get a fraction and you have to write it in lowest terms, you have to reduce it? You could reduce a fraction, but you can't reduce this one, so you have to do the opposite of reducing. So what could you do? Thomas?
Can you like add them up? Like go like 5 to 10 and then 2 to 8?
No. You can't add them. Caitlin?
Or 5 to
You could multiply. You can multiply. So as long as you multiply the same thing to the top and bottom, you're going to end up with an equivalent fraction. So I could multiply by 2 on the top and bottom, and I would end up with 8/10. That's one equivalent fraction. I could multiply each by 3, the original by 3, and I would end up with 12/15. When my daughter was in, I think, 5th grade, she had to do a worksheet where she had to write equivalent fractions. And I told her that if you multiply by 10, that's the easiest. So another equivalent fraction would just be 40/50. And she liked that. She did the whole rest of the paper just by adding zeros. Those are all equivalent fractions. You could add 2 zeros to each and make it be hundreds, multiplied by 100. All right, the next one is a little bit trickier. It says write the ratio 2 yards to 20 feet as a fraction in simplest form. Now, sometimes when we're writing these kinds of things, sometimes we'll leave the original units, but in this case, we're not. We're going to keep all the same units. So we either need to change everything to yards or everything to feet. It's probably easier if we change everything to feet. Who can tell me how many feet are in a yard? Caleb?
3.
Not 6. Johnny?
3.
3. There's 3 feet in a yard. You know what you were telling me, Caleb? You were telling me how many were in 2 yards, weren't you? So there's 3 in 1 yard. 3 times 2 is 6. So there are 6 feet to 20 feet. So I'm going to write that 3 ways. I already wrote it like that. I'm going to write 6 to 20. And now I'm going to write it as 6 to 20. Now it asks me to write it as a fraction in simplest form. Here's my fraction. Is this fraction in simplest form or in lowest terms?
No.
Hannah? No? What could I reduce it to? Okay, so I can divide the top and bottom both by 2, and it works out to be 3/10, which is in lowest terms. So a lot of times we write ratios in lowest terms. Sometimes we don't. They're easier to work with if we write them in lowest terms. But like when we're doing probability, which a lot of you have already done with me, we don't always put them into lowest terms. But for what we're doing here, we do want to put them in lowest terms. Okay, questions about this before we go to the next slide? Okay, next slide has 2 examples for you to try. I'm going to pause the video, so if you're watching the video, you should pause it as well and try these problems. Okay, find a ratio equivalent to 7/9. Addison, can you give me a ratio that would be equivalent to 7 to 9? Okay, 7/9 is actually the same ratio expressed a different way. Can you give me one that uses different numbers in the ratio? Caleb? Okay. Caleb multiplied both by 10, so he did 70/90. Anyone have a different one? Johnny?
14/18.
Okay, 14/18. If you multiply each of these numbers by 2, we get 14/18. Kaylin?
21/27.
Okay, 21/27. She multiplied both top and bottom by 3. So those are all equivalent ratios. They're all technically the same ratio. All right, next one, write the ratio 3 gallons to 10 quarts as a fraction in simplest form. And I tell you there, in case you don't know, that there are 4 quarts in 1 gallon. Let's see. Hannah, how many quarts are there in 3 gallons?
There's
Good. 12 quarts in 3 gallons. So then, Hannah, what would that be as a ratio?
12 quarts. 10.
Okay, 12 quarts to 10 quarts, and then we need that in simplest form, so what would that be? Good, 6 quarts to 5 quarts. Now, some of you change this to a mixed number, but when we're writing ratios, you don't want to change it to a mixed number because then you no longer have 6 to 5, you have 1 and 1 to 5, which is not a ratio anymore. So you have to keep it in its improper form. Don't change it to a mixed number when you're doing ratios. Okay, any questions about this? Brian?
Top right of 3.5 divide all
You don't.
Oh, okay.
divide.
So you divided by 2. Did you do 3.5 over 4.5?
No, I did 709 divided by 2 well, 709 and then divided both the denominator and numerator by 2.
Okay. In general, we want to use whole numbers when we're using ratios, so we don't want to divide by anything that would give us a decimal when we're writing a
So,
fractions.
how do you get like down to like 14 over 18 and stuff like that?
We multiplied. So for this one, we multiplied by 10. For this one, we multiplied top and bottom by 2. If it doesn't work to divide, you can multiply and get the equivalent fraction that way. And then this one, we multiplied top and bottom by 3. Okay, good question. Do you understand it now?
Kind of.
Okay. It's like if we had the fraction 1/2, okay? So I have a circle. Here's half of the circle. I could cut that half into 2 parts. So now it's 2/4, but it's still the same amount of the circle, right? I could then cut those fourths in half, so I can multiply this by 4. Now it's 4/8, but it's still the same portion of the circle. It's the same as equivalent fractions. Okay. Any other questions before we go on? Okay, let's talk about comparing ratios. When you're comparing ratios, write them as a fraction. And there's actually a couple different ways to do this, but the easiest way is just to divide the fractions. If they are equivalent ratios, the result is going to be the same. Another way you could do it is you could reduce the fraction to see if they both reduce to the same fraction. But if you're using calculators, it's probably faster just to divide the numerator by the denominator. So you're going to change them to a decimal, just like we did in the warm-up, and see if that decimal is the same. So when I do 34 divided by 4, I get 8.5. And you can do that on your calculator. You don't have to do it in your head, although this one is fairly easy to do in your head. 17 divided by 2 is also 8.5. So these are equivalent ratios because they're exactly the same when I divide them through. So yes, they are equivalent. Make sure you write down what I did so that whenever this appears on your homework or appears on your warm-up tomorrow, you have an example to look back at. Okay, the next slide has 3 problems for you to try. So I'm going to have you work on those. If you are watching the video at home, you should pause at this point. Try these by yourself. So you're dividing the top by the bottom. You may need to rewrite them as a fraction first. Okay, number 1, Halen. How would I rewrite these as fractions first?
730.
Good. And
is it 128? Oh, it's 54.
Good. It's probably easiest if you rewrite them as fractions first so you remember what to divide. What did you get as a decimal when you divided 7 divided by 3? Did you write down what you got or did you just do it?
I was doing it across from each other. I did like 3 divided by 54.
Okay, that you actually don't want to do. You want to write them as fractions and then compare each fraction to itself. There's another thing that we can do, but it doesn't involve division. Mackenzie?
2.3 repeated.
Okay, you get 2.3 repeating, and then what do you get when you do this?
I got 2.2
Okay, it's actually 2.370 repeating. So those are close. They're very close ratios, but they're not the same. So the answer for this one would be not equivalent.
Did you get 2.3? Yeah, I know. I don't get that.
Okay, let's take a look at that. Okay, when I do 7
Oh, I see. Yeah.
divided by 3, I get 2.3, and it just keeps going. My calculator stops, but it really does keep going. So 2.3 repeating, 128 divided by 54 gives me 2.370, and that actually keeps repeating. Okay, number 2. Jace, are these equivalent ratios?
No.
No, why not?
Cause I don't know.
Did you divide these through?
Yeah.
What did you get? Did you write down what you got?
No.
Okay, somebody wrote it down. Hillary. Okay, you get 0.75 for the first one. What do you get for this one? You rounded up to what?
Because it was like this.
Okay, let's take a look at what we get, because it doesn't actually round up. Okay, I want to do it up here anyhow because I want everyone to see it. Let me pull that calculator back up. Okay, so let's take a look at this one together. 25 divided by 34 gives us 0.735294. So this would not round up to 0.8, it would stay at 0.7. Okay, this is what you should have gotten, so you must have typed something wrong in there. This obviously, shh, guys, too much chatter. This obviously is not just plain old 0.75, so I'm going to write 0.74. This would round to, so these are not equivalent.
I have a question.
Yeah.
Can we just put like with not equivalent, we put like an X? And
No, you need to write so I know exactly what you mean. Mackenzie?
I put 0.73.
0.73. It's 0.735, so you would round up to 0.74. The important thing is that you notice they're not the same, but it is important also that you're rounding correctly, so it should round up. I'm going to just hide this calculator for a minute. Okay, number 3, and these ones are actually written as a decimal. Brian, are these ratios equivalent? Yes, they are equivalent. When you divide these, you get exactly the same number, which is 0.87142 repeating.
I just rounded up to a point.
Yeah, you just want to be careful when you're rounding. First of all, that would round to 0.9 because the digit after the 8 is 7. Make sure you write enough digits down so that you can compare, because if you round too soon, you might get two that are very close but aren't equivalent. Like, for example, this one. If you had rounded these incorrectly both to 0.7, you might think that these were equivalent. Same with this. If you had rounded these both to 2.3, you might think they're both equivalent.
Just asking, why did you go equivalent with the R there and then not with the R there?
That's not an R, that's a V. Okay, last one is an application. An official U.S. flag has a length to width ratio of 19 to 10. So if the length were 19, and it's not saying that the length is exactly 19, that's the simplest form of the fraction. So the length is 19, the width is 10. It has a 19 to 10 ratio. The largest U.S. flag measures 505 feet by 255 feet. Is this an official U.S. flag? How would I figure this out? Mackenzie? I don't think it's mine because I'm certain that I turned my volume down this morning. It's coming from my desk drawer. All right, I'll look at that in a minute. Okay, so 19 to 10. Guys, let's get back to this. How would I figure out if this is an official? Shh. Hey, too much talking. how would I figure out if this is an official US flag? What do I need to do?
And then see what the symbols are.
Okay, good. Hillary said divide each of them to see if they're the same. So I'm gonna go 19 to 10. This one is 505
Can I figure it out for you?
by 255. I want you guys to do this on your calculators. Figure out if these are the same. I'm gonna pause this for just a minute. Okay, Hillary, is it an official US flag?
No.
No, why not?
Because one's 1.9, and then the other one's 1.9803121.
Okay, we'll stop after the 0 there. So they are not the same. It's very close to being an official flag, but the answer would be no. It is not actually an official flag.
Goodbye.
Okay, your assignment. Yes, you can just write now. I know.
I think I'll leave it.
Okay, I would like you to do this
Yeah, I
assignment.
bet you this
Bro.
one is all
Thank
right.
you.